This next topic that we're going to cover is arguably the most important of these advanced topics because it's directly related to what we've learned. We're going to learn how to take all of these commands that we've been learning and putting them into reusable scripts. This can be very useful for things that you do over and over again, maybe system management commands, or even building different pieces of a particular code base. That's how it's used in a lot of different code bases. I wanted to show you the basic way of writing a script first and some of your basic syntax that you might have. So I'm going to touch an example script.sh, and then remember we always have to give that execute permissions if we want to run it. So we will chmod it. And when I run it at first, it's not going to do anything because we haven't put anything in it. But we can go in there with Vim and write a basic script. So it's going to look like this. You first need a shebang line, which tells the script where do I look for the particular shell that you want to execute this script against. And then you can put in any commands you want. So something like I am a script, the echo command. And if we run this, we should see that this now prints I am a script, and you've written your first bash script. But of course this is completely useless, and you might as well have just written, echo I am a script on the command line. So we want to get into some things that are a little bit more useful, and to do that we need to understand how we write different variables, built-in variables, functions, if-then statements, and for loops. So basically everything that you might see in a regular programming language. So to do that, let's just hop back in that file. And the first thing that we'll be doing is covering the variables. So it's very similar to what we talked about at the very beginning of this video with the whole concept of environment variables and stuff like that. So we can just define a variable pretty easily. Just say my var, make sure you don't have any spaces there, equals I am a script. So we're going to set it equal to a string, and instead of echoing out the actual string, we're going to echo out our variable. So we refer to a variable by using the little $sign right before it, and that's as simple as it is. So we can run this script and it should print the same exact thing. And it does, so that is how you use a variable. Now, if we wanted to use something called a built-in variable, we could do that also. And I'm going to hop back to my slides because I have prepared a little overview of the built-in variables in Bash. So you can see we can use these little phrases here. So obviously we need to refer to the variable using the $sign. That's why all these have the $sign in front of them. And then we have all of these built-ins. So 0 would be the name of the script. 1 is going to be the first argument of the script. And then you could go all the way to 2, 3, 4, 5, 6, 7 on to infinity, depending on how many arguments that you actually have in your script. So that would be the arguments, built-ins. Then you have a way to count the number of arguments right here with the hashtag. You can also throw all the arguments into, I believe it's an array, you have to check me on that, but it throws all the arguments together into one variable. You can also print the process ID for using double $signs. And then finally, a very useful one that we could use is the exit code, which is basically the exit code that we get from the most previous command. So if you don't return a value from, maybe you're running a function that could return a value which could qualify as the exit code, or if you just run a script and assume it doesn't error out, it's going to return something like 0. And if it errors out, then it'll return 1. So that's a very useful command for understanding like how your scripts are running and doing check conditions to say, okay, if the last command failed, then we need to exit the entire script. Okay, so let's try that out real quick. I'm not going to go through all of them. I just wanted to show you kind of how that works. So maybe we'll start with the exit code because that's just a pretty useful one that we're going to get to in the future. So if I run the command, well, I didn't need to do that there, but let me just run the command ls, which is going to print all of the files in my current directory wherever I'm running this script from. And the way that we want to check the condition of that command, obviously we're going to know if it works because it's going to print something, but we could also put in the $? and that's going to give us hopefully a 0 for a successful previous command. So if we run the script, we're going to get all of the stuff that I have on my my home directory here, and then here at the end is the 0 that we were looking for. So that's how you would use a built-in variable. We can combine this kind of discussion into the topic of command line arguments. So as we saw, we previously did not actually put any arguments against the script, but we could do space separated arguments, so maybe 2 and 5. So if I wanted to add these numbers together in my script, maybe my script is simply an addition script, I could do that, but first I need to go into the actual script and edit it. So let's go into the example script, and instead of doing all this useless stuff, maybe we wanted to print out the sum of it. So we could say echo, and then one thing to note is within double quotes you can actually still include variables. So if I wanted to print the name of the script, I could just put that in quotes. Now if we had single quotes, that's not going to work. So that's just a word of caution, because most languages kind of don't treat single and double quotes any differently, but Bash does. So just know that. So my script named, and then we'll give it the built-in variable that would be the name of the script, equals, and then we can print out the addition problem of the 2 arguments that we have. And now in this case we're going to assume that we have exactly 2 arguments. We're not going to check to do any validation here. We'll just assume that we get the perfect user input. So to do this, we're going to have to write a little bit special syntax here at the end to evaluate the addition problem. We actually have to put everything in a variable. So to print the addition of, or the sum of these 2 variables, we need to throw everything in a variable, and then we need to isolate the addition problem with another couple parentheses, and then put the first argument plus the, or actually no spaces there, plus the second argument. And that should print out the sum of our 2 arguments. So if we did example script and then 2 and 5, or yeah, 5, we will get the number 7. So it should print that out, and it says my script named examplescript.sh equals 7. So we got the correct expected output, and that would be how you use command line arguments. Now say you wanted to get the user to put in some of their input after the fact, like during execution rather than before execution. The way that we would do that is going into our script, and instead of writing this, we could say read, and then we have to read into a variable. So we could say user input is the variable, and then if we even wanted to make this confidential, like a password, we could put in, I believe it is -s. Let me check on that real quick. And that is correct, so we use -s to make this a confidential user input read. So maybe we will read a user password, and we want to prompt please enter password, and then we want a new line there so they can enter it on a new line, and then it's going to ask for the password, and then in true secure form we are going to print out the contents of that password, because that sounds like a very smart idea to do. So We will print that out at the end and see how it works. So let's go ahead and run this script. We don't need to give it any arguments at first. And oh, looks like my new line did not work there. That's okay. We're going to enter a password. So as you can hear, I just typed in a bunch of random letters, and when we press enter, it's going to actually print out what I just, mumble jumbled into the keyboard. And you can see that that is my highly secure password that has now been exposed to the command line. Alright, so that is how you would do user input and read it at execution time. Now the next thing that we'll get into is the concept of for loops. Obviously in any programming language you're going to need to understand how to do a for loop, because they're, I think, maybe the most important part of a programming language. And the way that we would maybe loop through the arguments in a program, this is just one example to demonstrate the syntax. We would say for maybe item in, and then we give it the variable at, so that, remember, means all of the arguments that were passed to our script. So for item in this built-in variable, and item is just an arbitrary variable that I'm using to refer to each individual item. We want to give it a semicolon and then say do. So this is what we want to do for each item. We want to echo the value of that item, and then the last part would be the done keyword, which says that we are done with our for loop. So that is the basic syntax of a for loop. We can run this script, and we'll make sure that we give it some arguments, maybe a string and then a big number, and what it's going to do is print out those 3 arguments for us. And you can see that it does that successfully. We printed out the first, second, and third arguments here. So that's the basics of a for loop, and I'm not going to, once again, this is just high-level overview, so I'm not going to get into many nuances here. We will next talk about if-then statements. And to understand if-then statements, we first need to understand the syntax, but then we need to dive into this thing called the test command. So let's get the syntax first. If we say if, and then we give it little brackets, and then I'm just going to put in as a placeholder, this will not actually work if we executed the script. We're going to put in our expression right there, a semicolon, and then the then keyword. And then finally, to end it off, we can either put else for an else condition, and then finally fi for the end of if, or we could just delete the else condition. So right now, this is not going to do us any good because it's not, the expression up here is not proper syntax, but we can do something here, and then we can do something in the else category here, if I can get the comment right. And that is the basics of our if-then statement. So we could say for each item in all our arguments, we want to do if maybe the current item is, I don't know, a string, then we will say this is a string. So we can actually start writing this before we get the logic. We can say echo this is a string, so we're gonna have to test up in that expression whether it's a string, and then we need to echo out this is not a string. So there's our script. It's almost done. We just need to understand that test command, and to do that we need to go into the man pages. Of all the man pages, most of them are kind of hard to read, but in this particular case we actually have a pretty straightforward man page. So if I type man test, it's going to give me everything behind the test command, which is essentially we're testing different conditions, and it's very useful with the if-then syntax. You're going to notice that we actually don't have a way to check whether this is a string or not, because bash variables are a little bit weird. They're not typed like you would see in like a Python or JavaScript, where you can just find the type of the variable. So we'll use this opportunity to combine the things that we've learned. So we'll look at a regular expression and a test command. So we're just going to use this basic equality, and we're going to check to see whether the argument is equal to our regular expression. So we're going to use this little test right here, and if we quit out of here and clear the screen, and we will go into our example script file, and in this expression what we're going to do, normally if we just had a bunch of strings, we could say maybe we could say, is the item equal to my string, or something like that. But in our case we want to check if it is a string, so what we have to do is say equal to, and then we're going to define our regular expression over here. So in this case we're going to say we want the beginning of the string, and then we want to say anything that is A to Z or capital A to Z, and if there's anything else in that particular or maybe we'll also throw in number. Well, no, we don't want to throw in numbers because it could just be a regular number. So we're going to stick with this. Our strings are, you could technically throw a number in a string, but our strings are going to contain only letters. And let's delete this little thing out of here. I don't know how that got there. And then that should match in a quantity of 1 or more. So we're not looking for any empty strings. We want at least one letter in there. So the last part before this is going to work is we have to throw this little tilde character in there to indicate that we want to match this regular expression against this variable. So that's just one little subtlety. I wouldn't expect you to know that given what we have talked about, but if you Google this little tilde indicates that we're comparing a regular expression. So let's get in here and see if that works. We will run our example script, and we will say valid string. I'm not going to put any spaces there because that's going to actually separate out the arguments, and then a number. So we should get the output, this is a string and this is not a string. And it's going to say binary operator is expected here. So we've obviously got something a little bit wrong. Alright, so I actually paused the video and figured out what was going on. I had thought that you could write this particular regular expression with a normal test condition, and as you see, what I had to do was add in these extra little brackets in here. Normally you don't have to do that, but in this case we do. So we're checking to see whether each item is a string with only letters, and if it is, it prints this is a string, otherwise not a string. So we should get the correct output at this point. So this would be a valid string, and then this would be a number. So it's going to say this is a string, this is not a string. Just a simple test condition. We could also do something maybe a little more straightforward. I know that was a little bit of a confusing example, but it goes to show the power of what we're doing here. So we could also put in something like, we'll assume that all the arguments are going to be numbers. So if the item is equal to 2, we will echo, we'll just take out the else condition, and we'll echo you entered 2 as an argument. So get out of there, example script, and then we'll say 2, 2, 2, 2, 4, 4, 2. So we have 5 2's in there, so it should print that 5 times that we entered 2 as an argument. You can also do a quick test of the test command just within the terminal. So if you wanted to maybe check if you're using it correctly, so if we ls and just maybe look at a file, so vimexample.txt, that is a file. So if we wanted to test that, we could use the -f for test if it's a regular file, and then type in vimexample.txt. When you press enter, it's not going to give you anything, But we can then echo out, or we can literally just type the $? and, well, actually, yeah, we do have to echo it, and it's going to give us a 127 because this command was invalid. But let's go ahead and run the test again and then echo ? And we get a 0 for this test was successful. Now if we did a maybe directory, so if we tested, rather than vim example, we said public, which is a directory in my current working directory, we can press enter, and then when we echo the exit code, it's going to be 1 because that's a false condition. So that's the test command. It's how you use it with the if-then statements, and it's very powerful for scripting in Bash. The last thing that we'll cover in Bash scripting is going to be functions. The basic way that you would write a function in Bash is going to be like so. So we can say custom function, just the name of it, give it these 2 parentheses, and then close it off with brackets here. So this is our custom function, and we can put whatever we want in it, as well as a return value. So if we returned the number 20, we can come down here to the bottom, and when we run the function, it's going to return 20 to the exit code. So if we printed out the exit code afterwards, this whole entire script is going to first define our custom function, then it's going to call it, and then it's going to print the exit code of that function. So let's try that out. Example script, and you see that it printed 20. So we printed the return value of our called function. Now we can also pass in arguments to the function, just like we can do with our script. We can do it with our function. So if I came down here and went to the end of this function and added in maybe 20, 30, and 40, we'd be giving it those 3 arguments, and then within the function itself we can actually do something with those arguments. So in this case, since they're all integers, maybe we're just going to I don't know, add them all together. So we echo out, and remember we have to do this a little bit weird syntax on this, but we got to do these extra quotes and then say 1 plus 2 plus 3. And so that should equal 90. And so we're going to basically echo out 90, and then it's going to return 20, and then we're going to later echo out the exit code, so that'll be 20. So we should get 9020 from this script, and let's try that out. We get 9020, and that is the basics of writing functions. So high level overview, I know, not a lot of nuance in there, but that is the basics of writing Bash scripts. Hopefully it gets you started. Be sure to look on Stack Overflow if you have any questions further than the basics.